So let's continue. Problem 3, force acceleration 1. And in the previous part, we find out the angular acceleration of drum with the block. And now the second scenario is the block is removed. Remove the block, and what is alpha D when we apply the force 12 pound to the cos, but not the block, and explain the reason for the difference. So let's continue with that scenarios. So the scenarios is remove block and apply 12 pound force. So by now you may imagine, before we solve the problem, you may imagine, should the alpha D change, the angular acceleration of the drum will be changed if instead of the block 12 pounds, now the force 12 pounds. And why is that? So let's solve it, and then we when we get answer, can you predict now and see whether you do correctly? Should it alpha of the drum now is bigger or smaller? So of course now it's only one rigid body, which is drum. It block already removed, so you only have one free body diagram and one kinetic diagram. So as you can see, the same step, free body diagram equal to kinetic diagram, and you still have x y direction, and this is only the drum, so we have drum and no more block already removed, equal to drum, and we also have the same center of mass is A, also G, A, also G. And free body diagram we will have same. It will have AY, you will have AX, and you will have the weight, in this case 20 pounds, and the force applied, the force applied is not the block, so the force applied directly to the drum, so that one is instead of T, now it will be 12 pounds. That is the question give us 12 pounds. So when the 12 pounds apply, that as you can see, it will be A fixed, so it know again, it know MAGX, MAGY, only IG alpha. So IG alpha in this case, what is IG or IA? It will be 0.397, so it will be IG alpha equal to 0.397 alpha. So from that you can have to just find out alpha, so you don't need to, you can of course use x, sum of all the force in x and y direction, but that we don't need phi ax ay. If you want, you can go back to here to do the same there. So now if we only interest in alpha, the new alpha, so that new alpha here, so you will have sum of all the force moment, about A, so T same as A in this case, and we assume clockwise is positive and equal to IG alpha. So from that we can have the equation is IG, so 20 pounds go through A, AX, AY go through A. The diameter of this one remain unchanged, 1.5 feet. So you will have it 1.5 times 12 equal to 0.397 alpha. So one equation of one unknowns, you will have it alpha equal to 45.3 radian per second square, and it positive, so it will be clockwise. So it's the answer for the second scenarios. Now compared to the previous one, I'm not sure you predict correctly. The alpha is increasing. It's actually triple from 1455 to 45.3 radians per second square. And the question I explained why. So that you can see apply 12 pounds force to throw it different from hook a 12-pound block to throw. Because when you have 12-pound blocks, you also have the mass of the block. And if you recall, the mass is resistant to the acceleration. So when you have the block have a mass resistant to acceleration, that's why the previous one, when you have block, the alpha, the acceleration, in this case angular acceleration, significantly reduced compared to apply 12 pounds without the mass. You get 45.3 radian per second square. With that, we're done for this long problem.